Oh,
You're recording.
I'm recording. Okay. So yes, we are recording now. Does anybody have any questions from the syllabus or calendar? Anybody have any general questions?
Oh, actually, one question on
Sure.
the not kind of syllabus for the quiz for WebAssign. Is that going to be due on Sunday night? Same with the quiz that's going to be assigned today.
Okay.
Like the thing that we do out of percentage based.
Right. Yeah, I've made everything due by midnight Sunday night. There is no late penalty. I don't keep track of late penalties, but I have to put a deadline on it. So when I do start collecting grades and recording grades, anybody who hasn't turned it in, you know, I can give them a 0 because they're past the deadline. But if you, you know, turn it in,
Thank you.
yeah, you turn it in, you get credit for it. Anybody having any trouble finding anything in D2L? That seems to be a common thing in my other classes. I've got D2L pulled up here. I can get to it. I hear a hand of Mr. Pablo Gonzalez. You got something?
Yeah, I can find the Google form and the question numbers in D2L. When I go to WebAssign, I can't find the actual assignment.
Okay, let me see if I can pull up the instructions I put and see if that'll help. I don't have WebAssign pulled up. Can you see this? It's my 4 classes on the front homepage of D2L. Is that showing up?
No, it's not.
What are you seeing?
We're seeing the notepad.
Still seeing the notepad.
Oh, yeah.
Okay. We'll
Let's switch gears.
okay, can you see it now? The front page
Yeah.
of my D2L.
Yeah.
Yes.
Okay. I'm going to see if you can follow this through. So we'll click on my class. Okay, and let's see, all these words up here, I click on the word content. Okay, again, there's stuff under overview, and then at the moment, module 1, I've got the instructions. I'll just start with module 2, and so here it is. And then you said you were having trouble getting to WebAssign?
Yeah. Or not getting to WebAssign, but when I get to WebAssign, I don't see any assignments listed or anything on the calendar there.
Right. That is because the assignments are not there. See, what happens is if I make the assignments there, WebAssign assumes that you want to work all the problems, or I want you to work all the problems, and I don't.
Okay.
They go into some of them that are real strange, and we don't have time, and I don't want to mess with. So I've got the instructions right here to access the WebAssign assignments, and then the actual assignment is right here. So what I have done is picked and chosen among the problems. So 5, 6, I got 1, 2, 3, and 4. I think there were more after this I'm leaving off. And in 5, 7, I think I had you do all 9. They looked good to me. So what I'd like you to do for a grade, there's 13 problems here. See, when you access it in WebAssign, like problem 1, you can work and enter the answer and go to the bottom of the page and hit submit. It tells you if you're right. If you're right, great. You go on the next one. If you want to, you know, keep working on it and try again, fine. But at the end of it, the idea is to figure out how yourself, don't read the WebAssign grade, because see, by leaving off problems, WebAssign is going to give you a lower grade. You're going to mark the problems you leave off wrong. So by the end of it, if you get all 13 right, then you can tell me you get 100. If you leave one wrong, 12 out of 13, you can tell me that percentage. So you
Okay,
actually
I found quizzes now. from the website. I found website quizzes.
Okay. So what's the question?
So the assignments, the practice problems themselves aren't on WebAssign. They're just,
The practice problems themselves are on WebAssign. They are problem 1, 2, 3, and 4 out of that practice quiz for section 5.6 under your personal study plan.
I see now, okay. And the 5.7 problems are in the 5.7
Are under
natural logarithmic
5.7
function. Okay,
practice quiz, yeah.
okay, I see where it is now. It was just, since they weren't,
Right.
okay, yeah, you got it.
See, this is what frustrates me, yeah, about online. Ordinarily, we'd be in room 182, everybody have a computer, and when you have a question like that, I come over and personally show you, which is, to me, is the best way to explain it. But obviously, under these conditions, they're not allowing us to do that. So let me point out where you're going to report your grade, because you see, when the WebAssign is going to give you a lower grade because I've left off some problems.
Yeah.
So what I want you to do is go to this WebAssign Google form for grade, and you're going to enter your email address so I can identify you, and you're just going to tell me what percent out of, was it 13? What percent out of 13 you got right? Just give me the number. If you got all of them right, you got 100%. Just enter 100. Does that help?
Yes.
Okay.
That's my question. I got it now.
Okay. We're going to do this for the entire semester. So next week, it'll be sections 5.8, 5.9. I'm trying to be very consistent in the format, so once you learn it, it's going to stay the same for the entire semester. Any other questions about this? Okay, don't hear any. I'm going to try to get back to my camera. Anybody have a problem you want worked? I do the stop share, right? Screen, back typo, and share. Okay, we're getting our camera set back up. Okay, we're back to the notepad. Can you all see that?
Yep.
Okay. Anybody have a problem out of the book you want worked?
I do.
Okay.
You can go if you want.
No, you can go first.
Can you
Okay.
give me a page?
So I wrote down on this sticky note. I don't know if you can see it.
I don't have that. I don't have your screen. If you want to share the screen with me.
Here, I'll just read it out.
Okay.
So, the integral of cotangent parenthesis theta over 7 d theta.
Okay. Can you give me a page number and problem number just for people watching the recording?
It was on the WebAssign.
Oh, it's WebAssign. This would be for 5.7.
Yes.
What problem number was it?
3.
Problem 3. Okay, very good. All right. So you want to just see it worked out?
Yeah.
Okay. If you have a straight letter and it matches this, it charges in much easier. But because they showed you this divide by 7, we've got an initial substitution to do. They generally call this UDU substitution. That's the other thing. I haven't really been able to review any of Calc 1. I hope everybody knows all the derivative rules, all things from Calc 1, and you may or may not, depending on how long it's been since you had Calc 1. In the regular class, when I've taught this, I go through really a whole class just reviewing major points from Calc 1, but I really haven't been able to do that. But on this one, you're going to start with a U to U substitution. You're going to make your U the theta divided by 7. Divide by 7. Okay. You do a derivative on that. That gives you the du. There's a delay before it shows it on the screen. And we just froze. No, here we are. And we will make that 1/7. So the coefficient for the derivative is 1/7 d theta. Okay, any questions so far? If you want to see the 1, you can go it up here, but it's like taking the derivative of 2x. It's a linear, so the derivative is your slope over the coefficient. I could have written the d theta down here, but we like to match what's up here, so we multiply both sides by the d theta.
Okay.
Okay, so now I'm going to sub in. And I will get integral cotangent of u. Here's the u. In effect, this is the u. Now, to make this match, I need to put the 1/7 in. In fact, maybe I should show you, maybe I should slow this down a little bit. Maybe I should leave it theta over 7. I'll still leave it theta over 7 at this step. And I'm going to show the 1/7 d theta. And then to fix it, I'm going to need a 7 outside for a fix. So I've got the entire original integral here, but I've stuck a 1/7 here, fixing it with a 7 outside, so nothing has changed off the original integral. Well, now I have a front coefficient of 7. And now I'm subbing in integral of cotangent of u, and then the rest of this 1/7 d theta is my du. Stop for any questions. I could label it up here. This is my u. The rest of this is my du. And it needs a fix of a 7. Don't hear any questions. So to work this out, a cotangent by trig is a cosine of u divided by a sine of u. Sine of u, so I apologize. Sine of u du. Okay, now I need another kind of substitution. I'm going to play the same game, but I need another letter. I guess I'll use A. Like A is sine u, dA, cosine u, du. And on this, I don't need a fix. I can write this as 7 integral 1 over A dA. So my A goes in for sine u, and my dA is my cosine u du. And my screen seems to have frozen again. Screen's frozen again.
Okay. Well,
Oh, it,
has darkened.
yeah. The dumb iPhones.
But bear with us for a moment.
Yeah, bear with us. Technical difficulty. Okay, here we are. We're back. Let's put it on that video thing next time for next class. Okay, stop for questions here. We're 2 substitutions deep into this one. Have we lost anybody? Is anybody out there going, whoosh, what is all this gibberish? I'm getting no response. Can y'all even hear me?
Yeah, we can hear you.
Okay.
This is definitely a bit of the confusing thing because like my question, what I was gonna ask is if you could kind of explain how this works. That is definitely helpful. Could you maybe do another one of these type of problems after?
I would be thrilled. Absolutely. Anybody out there going, why did I sign up for this class? Okay, well, let me finish because we're probably 5 steps still from the end. Am I ready to go on and finish?
Yeah.
Do you recognize this integral as a log? You're ordinarily used to an integral of 1 over x dx. Hopefully you remember, I did show you this in Calc 1 as a log of x plus c. Probably used to it in x. But anytime you got a first power on the bottom, it's a log. We just happen to be in letter A. A lot of times you will see the x in absolute value. That's just because you can only put positive numbers into a log. That's why they show that. I'm a little slack about it. Sometimes I put them in, sometimes I don't. I won't mark you wrong if you don't put it in. So this works out as a 7 natural log of an absolute value of A plus C. Now it's a matter of working our way back through the substitutions till we back to the letter theta at the top. So 7 natural log, our A is sine U plus C. And what was the darn U? Well, it's right here at the very top here. U was theta over 7. Final answer, 7 natural log sine theta divided by 7 plus C. Now, if you actually wanted me to check it, you could do a derivative on this and you should come back to the original cotangent at the top. I would be thrilled to show you that. It'd only take another 4 or 5 steps. Or you can punch this into WebAssign and let it tell you right or wrong. What do you prefer? I don't know what you think about the difficulty of this. This one is fairly difficult, I guess, for right now. Compared to what's coming in chapter 8, I assure you, this is kindergarten. Chapter 8 is going to have substitutes. Some problems go 3 substitutions deep. Sorry to wake you up with bad news on a Friday morning. Anybody want to feed me another one? You asked for a similar one to this. Anybody want to feed me another one?
I guess one of the book problems on page 362.
All right. I got the book.
I don't know which one.
362.
Okay. 25.
25?
Yeah.
Got it. Page 362, problem 25. And it reads 1 over the square root of x, 1 minus 3 square root of x dx. Okay, are we on the same page, so to speak? This is from 5.7. Okay, you generally want to make, again, it's going to work by a straight u du substitution. You generally want the u to be the more complicated thing. That's going to make our u this piece. That's the hardest thing about these problems, is knowing how to get started. We'll make our u 1 minus 3 square root of x. You then want to do a derivative, and that's why you need to know all the derivative rules. Because whatever the u is, you need to be able to take a derivative of it. And we've frozen. I've written down my du, but my hand isn't moving. We'll work out some of these technical difficulties by the next page. Okay, here we are. Now, on a derivative, a number goes to 0. Don't have to mess with a straight number. We'll need a -3 for the coefficient on this. Hope you remember a square root's in a half power, and it works by straight power rule. Half comes down, x, and you subtract 1, so a half minus 1 is a negative a half power, and dx. Now I can clean this up a little bit by collecting the -3 over 2. And I can write it 1 over x to 1/2 power dx. And to make it look more like it matches up here, I'll switch the half power back to a square root. So I finally get du is -3/2, 1 over square root of x dx. Pause for station identification. Did we lose anybody? Any questions about that? What I've discovered over the 32 years of teaching this class is that things can be obvious to me, but they're not necessarily obvious to thee.
Or I might as well ask it. For the u, why didn't you do the bottom square root? God, I can't say the word. Square root x. Got it.
Why didn't I make the u just this?
Or why didn't you add that?
Okay, I'll show you why I didn't add it. See, that's the frustrating thing about this class, is that there's no real formulas to memorize. It's a lot of tricks. And the only way I can really justify it, you can try making the square root of x, making your u this. You can go over here, you can try this. U is square root of x. But what you'll discover when you do your derivative, you get your 1/2 x -1/2. And you won't really be able to match the rest of this. There's no way to really bring in the 1 minus 3. So you try, it's really called trial and error. If you want to try it, help yourself, but you discover you got no real way to match this. Whereas if I make the u this, and again, I just know it from experience because I taught this stuff for 32 years, I can wind up with this, and I'm going to show you how to match it here in the next step.
Okay,
Right.
thank you.
Are you ready for that?
Yeah.
Okay. To make it even more obvious, I'm going to switch the square root here to the end. So I'm going to write the original 1 over my 1 minus 3 square root of x, and put that initial square root at the end and write it 1 over square root of x dx. Because it doesn't matter, the order you multiply doesn't matter. Now, see, I'm trying to make this really super obvious. This has got to form my du, and I'm almost there. I'm just off by this -3/2. So I'm going to put that in. But now, by itself, I've just multiplied the whole thing by -3/2, which is illegal. I must fix it. How do I fix it? Well, I've got to get this back to 1. So in the front, guess what I put? A -2/3. If it's a single number, like a 4, I'd put a 1/4. If it was a 1/4, I'd put a 4. Like last problem is a 1/7, I put a 7. You got to kind of do whatever you have to do to fix things. Questions about this? All right. So I now have this is my u. All the rest of this is my du because it matches. So I worked it to -2/3 integral 1/u du. And once again, that's a first power. That means log. -2/3 natural log. I'll use the absolute value u plus c. And I only have to put back in for the u. And that's right off this line right here. Final answer. -2/3 natural log 1 minus 3 square root of x plus c. Questions about that?
How'd you get -2/3? I thought it would be
Up here.
-3/2.
Okay. Look back up here. You see how I got this derivative?
Uh-huh.
Okay, I had to bring the power down. In fact, no, I'm okay. I'm stop one step check. I thought I was off by a sign. So back up here, I had to bring the power down. So -3, yeah, power down with half, x to the -1/2. Okay, so -3 times 1/2. So I get the -3/2. I put this back on the bottom. Changing levels switches signs. That's why it switches back to the half power, and then I made it a square root. Okay, by switching this initial square, well, up page here. By switching the initial square root to the back, I tried to make it more obvious. So I have it 1/square root x dx, and then I slid that -3/2 in. And so can you see I can tell that entire piece is my du?
Uh-huh.
Okay. So to fix things, I have to do the reciprocal in effect. Flip it, keep the same sign, because -2/3 times -3/2 is a +1. I could cancel it all and I'm left with the original integrals. So by doing the -2/3, I haven't changed anything. But that -2/3 then follows all the way through to the answer.
Okay. All right,
I
thank
could
you.
do a derivative on this and show you get back the original, but I don't know if it just adds more to the gibberish or not. You can look up the answer in the back of the book.
Okay, yeah, I got it now.
Okay. We are at almost 30 minutes. Does anybody want another problem?
Can we do problem 23 on that same page?
23, same page. Got it. Okay, so that's what my book says. Once again, unless somebody shows you how to start, it is a little hard to start, but you start by looking for pieces that are derivatives of other pieces. So in this one, I'm going to start with u as a straight log of x. And from Calc 1, your derivative, the derivative log rule, 1/x dx. Everybody remember that from Calc 1. The derivative of natural log is a straight 1 over its argument. With a straight x, there's no chain rule. Further on in the class, you're going to have to look for chain rules. You'll come to this step and it's an x cubed or a square root or something. And you'll do the 1 over whatever it is and then a derivative of that because you got chain rules. But with an x, there's, well, the chain rule is 1. Okay, again, to make this more obvious, I'm going to write this, I'm going to like slide a 1 in there. And I'm going to write this log of x squared times 1 over x dx. That's a times there. So I pulled the x out, making it 1 over x to match this. Do you see now that you have a u for that? And this stuff is the du.
Yeah.
So it sub in, basically a u squared. Your u is the log, it's inside a square, so that's u squared. The rest of this is du. Now this works out by straight power rule. Antiderivatives here, you add 1 to the power and divide by that. So this is u cubed divided by 3 plus c. And once again, I only need to plug back in for the u up here. Final answer, log of x cubed divided by 3 plus c.
Yo, slow down. Hold up. Yo.
Someone try to ask a question, it didn't come through. Does this go in the category, it looks so easy when I do it?
Where did you get the U3 over 3 from?
Okay. I don't know if you remember, a quick Calc 1 reminder. Let's say I have you do a derivative of x squared. I'll just start, I call this kind of forwards. You know what to do, right? You
Yeah.
bring the 2 down, x to the 2 minus 1. You bring a 2 down, and you subtract 1 from the power, which gives you 2x. If I do an antiderivative of x squared,
Oh, that's what you did. Okay.
yeah, this means I add 1 to the power and divide by that. And you're always off by a number, so you tack on a plus c. You can see the check in your head. 3 down cancels a 3, subtract 1 from this, and you wind up with the original x squared. So that's what you do on straight powers. You add 1 to this and divide by that. You can almost see the check on this one in your head. 3 down cancels the 3. You wind up with log of x squared because you're subtracting 1 there. And derivative log x is 1 over x, and that's where the 1 over x comes from. These almost have to be cooked to work like that. We're at almost 35 minutes, so these are getting pretty long to upload. Does anybody want to ask anything else? Okay, let me just tell you, today I'm going to post in D2L your syllabus, quiz 1. It's going to have 5 problems from 5.6, 5 problems from 5.7. The problems will be all worked out. But some will be right, some will be wrong. In effect, you're going to grade me. You're going to put your answers on the Google form that'll be right next to it. All of the questions will read true or false. The problem is correct. If I did it right, you put true, enter true or false, capitalize, just the first letter. I'm going to keep the same format for the entire class. Try to keep things simple as I can. And so it'll be 10 questions. You'll answer true or false. The problem is correct. If the problem isn't correct, you put false. You're going to submit the Google form, and it'll tell you your grade instantly. And we're still at the stage, if you got some wrong, you don't like the grade, you can resubmit. We'll have that available today. It's due by Sunday night.
Okay.
Any last questions before I sign off in the meeting?
How many attempts do we get for the quizzes?
At this point, unlimited.
Or-
The average of them is 20%. When we get to the tests, you'll get one submission on the test. But it'll have the same format.
As the practice problem?
Well, the tests will have problems that we've gone over, and we'll be from the practice problems, and yes. But I mean, it'll have the same format. The problems will be all written out, and you'll answer on a Google form, true or false. The problem is correct, or false, it's not correct.
Mr. C, I just have a question.
Okay?
For the questions you were showing us from the textbook, we need to find what U equals and DU equals.
For these integrals, yes. That can be the hardest part, is knowing what U or DU to use. A solutions manual can help. Sometimes you can Google it on YouTube or Google it. You might find where someone's worked something out similar. But yeah, there's no absolute rules about the U. Once you know the U or use a U, the DU works by the derivative rules. But there's no absolute rules about what the U can be.
Mm-hmm.
Any other questions before we end the meeting? All right, thank you all for showing up. I really appreciate it. And we will have Google meetings next week. I'm gonna try to keep the same schedule. Tuesdays and Fridays at 9 a.m. Thank you very much.
Thank you.
Okay, thank you.